Alright, so last unit we talked about matter and how it's made up of atoms. This unit we're going to talk more about the structure of the atom and how we came up with that structure because we can't see atoms. So we're going to start by talking about some early theorists and their ideas about what the atom was. So the first person given credit to the idea of the atom is Democritus, even though he came up with a lot of these ideas with his mentor's help. And basically, he said that matter is made up of empty space through which atoms move. They're tiny, indestructible objects, so you can't destroy them. And that different atoms have different sizes and shapes. He also said that changes in matter are due to changes in the combination of atoms. So anytime that you change something, you're changing the combination of atoms. Lavoisier came up with the idea of conservation of mass, and this is a very, very important idea, and we're going to deal a lot with it when we get to stoichiometry and also equations. So he basically said that mass or matter cannot be created nor destroyed. So anytime that you change something, you don't actually destroy the atoms or make something brand new. You're just changing things around, but you can't create matter or mass or destroy it. So it has to go somewhere. Now Proust came up with the law of definite composition, and he said that a compound will have the same composition regardless of how it was made. And really what they were looking at were the mass ratios. So carbon dioxide, no matter how you make it, what proportions you give of oxygen and carbon, it always comes in 12 to 32 ratio. And I'm sure you can get a smaller ratio out of that, but it always had 32 grams of oxygen for every 12 grams of carbon. So they were really looking at the mass ratios here, but the idea is that no matter what, a compound will always have the same ratio. So water will always have 2 hydrogens for every 1 oxygen. N2O would always have 2 nitrogens and 1 oxygen. And now we're going to look at Dalton. Now Dalton's atomic theory had 5 postulates, and a lot of them we still hold to be true today. His first postulate was that all matter is made of small, indestructible particles called atoms. Also, that atoms of the same element will have identical properties. So if that's true, if you have different elements, they should have different properties than another element. So gold and silver should have different properties, but the individual atoms should have the properties of that element. Atoms must obey the conservation of mass. So that means that you can't destroy atoms, nor can you make them. And also atoms will obey the law of multiple proportions. So the law of multiple proportions is also called Dalton's law. It says that if 2 elements can make more than 1 compound, those compounds are always combined in a whole number ratio. There was a lot of math involved with this, and they were really looking at, again, mass ratios and comparing different compounds, but I just want you to understand the basic gist of this. And I'm going back so I can look at this picture right here. So nitrogen and oxygen can make several different compounds. So NO, it can be a 1-to-1 ratio. It can also be a 1-to-2 ratio, 2-to-1 ratio, 2-to-2, which is the same thing as 1-to-1 anyway, or a 2-to-5 ratio. So you can have elements make different types of compounds, but it always come with a different ratio. So the law of definite proportion says that no matter what, when you make a compound, it will have the same composition all the time. So, like water will always have this composition, 2 hydrogens to 1 oxygen. But it can also make, hydrogen and oxygen can also make a different compound called hydrogen peroxide, which is H2O2. So the law of multiple proportions says that you can have two elements and they can make two different compounds, or more than that, but those compounds are always combined in some whole number ratio. All right, and I will see you next time.